Okay, now we start angles and arcs for our circles. One of the first things we're learning about our circles. And an important thing for us to note, some definitions here we all took in class. Central angle, that's where the vertex is at the center of the circle. We're going to learn about one other really type of angle. Right now the first one is central, so that would be, if I just trace it here, this type of angle, where S is the vertex and it's at the center. We have arcs, which are exactly what you'd think they are, sort of like an arc, just part of the circle going around this way, that type of thing. Minor arcs, major arcs, semicircle. Minor arcs, less than half the circle, 2 letters. That's the big deal to remember. Minors, 2 letters. Major, 3 letters. Semicircle, also 3 letters. So the difference being here, semicircle is exactly 1/2. So if you look at the 3 letters, and your 3 letters, for example, I, R, P, then that's a semicircle. Okay, not a major arc. A major arc would be I, R, G. So we'd go past the half circle. So I'm going to write a couple of those down. So minor arc would be, let's say, RP. With a little arc over the top. If we're doing major arc of 3 letters, I said IRG, for example. So IRG, again with a little arc over top. And the same thing with semicircle. We said that would be IRP with a little arc over the top. All right? If you're unsure, just follow those letters, match them up. First example here would be central angle equals arc measure. This is awesome. Central angle's exactly the same as the arc measure, so we can follow these numbers real simple. First one would be arc RP. You notice there's nothing for arc RP here, but there is for central angle RSP, and we have 55 degrees. So then our arc, 55 degrees. We just sort of have to do that all the way around. If that's 55 degrees, we know this here is 180 degrees. 180 degrees is our best friend when we're talking about circles. So if this is 55 degrees here, this guy is whatever adds up to 180 degrees. So we get, what, 125 degrees? So I can write that down, 125 right now, 125 in here. That means if that's 125, so is this guy out here, right? That's awesome. We can just kind of work our way around. So let's check these out. We need angle GSP. I know there's no angle there, but if there was, angle GSP would be the same as the arc of 55 degrees. So we have 55 degrees there. And then we have next arc PGI. So PGI, oh, look at that. 3 letters, halfway around exactly, 180 degrees, no calculating, no adding, no thinking. Oop, my bad. 180 degrees. PRN, our next guy, PRN here, so we follow it. PRN. Well, once we get to PI, that's 180 degrees, right? Halfway around the circle. And we just need to add the 20 to it. I don't care what these other numbers say. We know this is halfway around, 180 degrees. Add a little 20 to it. We get 200 degrees. Next one is arc PN, right here. So PN. Why am I not going this way for PN? That goes back to minor and major arcs. If I notice that it's 2 letters, I want to go the short way, less than halfway around the circle. If I notice it's 3 letters, then I go the long way around the circle. So I know that that's one of the first few things we got to figure out. PN, PN, less than halfway around the circle. All right, so now I got to figure this guy out. Looks like I have something here I'm missing. You know, I can figure that out. I have 180 degrees for the whole thing. I know this is 55. I know this is 20. And if I add those up, I get 75. I subtract the 75 from 180. That tells me that what's left over here is 105. So I have arc PN. I have 105 plus 55, 160. And then I have arc, right, for fun here, RIP, RIP. And I got to go the long way, RIP. Another way of doing this is all the way around the circle, 360 degrees, from R to I to P. If I just subtract this 55 out of the 360, I'm left with the RIP. I don't have to add every little bit up. So take 55 minus 360, and if I'm correct, we're left with 305. It says then compare arcs, my bad. It says compare PR and PG, arcs PR and PG. That's easy enough. They are congruent arcs, and they are adjacent. And we all remember adjacent from being next to each other. Adjacent, that's what that means, next to each other. Okay, 6.5 minutes on the first slide. Here we go on the second slide. I'm going to first tell us how we can find all of our numbers here for our arcs and our angles, and then we'll just write them down, and maybe they can make some sense as we go through them. So first things first, this arc here is 65 degrees. This is a central angle, this GCF, and we established last slide that if it's 65 on the arc, it's 65 on the angle. For example, the guy here is 45 and 45, right? If it's 45 on the angle, it's 45, or whatever I wrote there, on the arc. Much better. Another thing to help us out, always I said, is the diameters here, halfway across, this 180 degrees, halfway around the circle. If I know this is 45 and that's 65, I add those up and get 110. 110 minus 180, right? Halfway around a circle is 180. Leaves us with 70 for this guy down here. If that guy's 70, this guy's 70. And now hopefully remember your angles. If this guy's 70, angle 1, angle 3 is also 70. They are vertical angles. If angle 3 is 70, the arc up here is 70, because this is a central angle, right? Arcs are the same. Those are the easiest ones. They're great. Now all we have to do is figure out what angle 2 is. A couple ways of doing that. It's technically vertical to this whole thing here. So if this is 110 over here, this is going to be 110 over here. Another way of doing it is to see that this is a diameter again, another one, and this is 180 degrees. So 70 degrees here, 110 there, and then 110 out here. So now as we write all our answers in, you can kind of add them up, subtract them, figure out where we're going. We're looking for arc AG to start. It looks like arc AG was 45 degrees. And we're looking for angle GCF. And we already talked about angle GCF. How funny. That's 65 degrees, right? The same as the arc. Arc AE, right here, arc AE, 70 degrees. Angle 1, 70 degrees, correct? Angle 2, 110. Angle 3, 70 degrees. Arc EB this time. Short, 2 letters, minor arc. I'm saying that to remind you. Has to be less than 180. Remember, EB, not EB. That's bad. That would be 3 letters. Short way, 110. BF, short way, 70 degrees. AFE, okay, so we're trying to trick you here. AFE, if I go A, E and F, wait, AFE, that's it, long way around, AFE, long way around, 3 letters. That's that whole 360 thing. And if I'm not including this here, I can just subtract the 70 from 360 and I get 290. Remember that trick, really helpful as opposed to adding up every single arc all the way around. Last one, ABF, ABF. Well, another easy way of doing it. A to B is 180 degrees, right? Halfway around. Add this 70 to that and you get 250. Alright, saving some time here, but this is definitely the meat and potatoes of what we're doing. We have to catch on. We have to do an equation now, of course. Now that we've given you these expressions, you have to catch on. I promise you that this is a diameter and this is 180 degrees. So I've taken the liberty of already solving this. This angle plus this angle equals 180 degrees. You all know it when I draw this half circle inside here. You go, oh, that's 180 degrees. So I've taken the liberty of solving the equation. 4x plus 3x minus 9, this one plus this one equals 180 degrees. Solve, 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 x equals 27. Then take your 27, substitute it in for any of the x's, find all your angles and arcs, right, because they're the same, because it's a central angle that we're dealing with. And I've then taken the liberty of solving a few of these just to show us where we're at. So arc AB, looking for this arc here. Well, that's the same as this angle, right? So I'm just going to take 3x plus 10. I did it right up here. I put the 27 in for the x, and I got 91 degrees. Same thing with CD. Arc CD, here's the angle. 2 times 27 minus 19, you can read it right here, equals 35. Arc EA, EA, here's the angle, 3x minus 9. I took my 27, put it where the x was, put it in a calculator, 72 degrees. BC is 54, arc DE 108. I do want to mention arc CDE. If you go CDE, that is definitely less than 180. It should be called arc CE, but it's allowed to be called arc CDE. Not trying to trick you or fool you, but just trying to show you that that's okay. It's your job to follow the letters, C, D, E. Go in that order. Don't assume it's a major arc and try to go backwards somehow. It just doesn't work. And then last but not least, CAE, CAE, 217 degrees. Yes, I had to figure out arc CB, arc BA, and arc EA and add them up to get CAE. And that's okay. That's some of the work that we have to do.